The eccentric height is like the real focal plane of the TEM microscope along the z-axis. For regular TEM imaging, it's not usually much of a problem if your sample is not exactly at the eccentric height. But for more specialized imaging, such as tomography and also for tilting, it's important to place your sample at the eccentric height. You put your sample at the eccentric height by using the Z-focus function. In the 1400s flash, the focus button doubles up as the Z-focus button. So when you press Z-focus here, this button becomes the Z-focus button. When you use the focus button to perform the Z-focus, instead of the microscope altering the beam to set the focus to where your sample is, the microscope will set the focus to the eccentric height and then bring your sample to the focal plane. To adjust the Z-focus, first click on Standard Focus and then select Z-focus. If your sample is not at the eccentric height, when you press the Standard Focus button, your sample will go out of focus. So with the focus wheel working as the Z-focus wheel, you can bring your sample back into focus. You should be able to hear small noises as the stage repositions the sample. Now the sample is in focus at the eccentric height, which means that it is at the real focal plane of the microscope. Now do not forget to press Z focus again so that this function is not lit up anymore. And now the focus button has gone back to being just the normal focus. If you're imaging structures that have a defined orientation, such as microtubules, the stage tilt function can be quite useful to bring these structures into a more favorable position for imaging. Every time you click on one of these buttons, you should see the goniometer move as the microscope changes the tilt angle of the sample. To return to zero tilt, press on TX neutral. Before you tilt the sample, you should adjust the Z height to make sure your sample is at the eccentric height. If your sample is not at the eccentric height, your feature of interest will move away from the center of the screen as you tilt it. Even if you adjust the Z height, your Z height adjustments might not be terribly precise, so it's a good idea when you're tilting to work at a magnification low enough that you can see a good area around the structure that you're trying to tilt, so that if this structure moves to a different position after tilting, you can bring it back to the center. I am now tilting my sample in 1 degree steps and bringing it back to the center. So basically, when I'm tilting, I'm using one hand to click in either of these two buttons here, and using the other hand to reposition my sample, bring it back to the center using the tracker ball. This is the same microtubular axoneme structure before tilting and after tilting by 13 degrees. You can see the microtubules in cross-section much better after tilting. With the specimen quick change holder, you can use tilt angles of about 20 degrees plus and minus.